We're going to start with graphing lines, but before we do that, we want to make sure we understand first how to graph points, and second, a little bit of vocabulary about our coordinate plane. So right here is a picture of a small coordinate plane, and there's a few pieces of this that we're going to label. So this horizontal line, it's numbered 1, 2, 3 going to the right, negative 1, 2, 3 going to the left. That's our x-axis. The positive values are on the right, the negative values are on the left. We also have a vertical axis. That's called our y-axis. Positive values are up, negative values are down. And this point right here in the middle, 0, 0, we call that our origin. Okay, so when we are, first we're just going to look at graphing points. So when we are graphing points or giving the coordinates of each point, when we say coordinates, we mean the location of x, comma, the location of y. We always start with our x value, and again, I'm going to label it. This is our x-axis. Positive is to the right, negative is to the left. This is our y-axis. Positive is up, negative is down. So if we're looking at the point A, we always start counting from our origin. We move to the right 1, so that means our x-coordinate for A is positive 1. And then we go up 1, 2, 3, 4. So our y-coordinate for A is positive 4. So we always start with the origin. We move our x direction first, whether that's left or right. And then we move our y direction, whether that's up or down. Okay, so if we look at point B, we move left 1, 2, 3, 4, 5 spaces. Left 5 is going to give me negative 5 for my x-coordinate. And then my y-coordinate, we go up 1, 2, 3. So that means positive 3 is my y-coordinate. And then our last point here is C. Notice if we start counting from our origin, we do not move left or right at all. So that tells me that our x-coordinate is 0. Then we go down 1, 2. That tells me our y-coordinate is negative 2. So when we're writing ordered pairs, always start with your x, that's our horizontal movement, and then do our y, that's our vertical movement. Okay, now let's do the opposite. Let's take an ordered pair, again, x comma y, and let's put that on the graph. So with our first point A, we have positive 3, positive 2. That means we go right 3 and up 2. That's our point A. For point B, our x is negative 2, our y is 1. That means we're going to go left 2 and up 1. That's point B. For point C, our x is 3, our y is negative 4. That means we go right 3 to positive 3, down 4 to negative 4. That's point C. Point D, our x is negative 2, y is negative 3. That means we go left 2, down 3. Point E is negative 3, 0. Our x is negative 3, our y is 0. So that means we go left 3, and that means we do not move up or down at all. And then our last point here, point F, is 0, 2. If our x is 0, that means we don't move left or right at all, and we just move up 2 spaces. So that's how we go from ordered pairs to points on the graph. Okay, now let's use that, because usually when we're talking about graphs, we're not just plotting a bunch of random points on there. We're plotting some kind of graph or some kind of function. In this unit, we're going to see some linear functions. We're going to be graphing some lines. So let's look at example 121. We're given an equation, y equals 2x minus 3, and we're told to graph that. We're going to make a table of values. This right here is our table of values that we're going to use to help us graph this. If you've worked with linear equations before, this type of graph may look familiar, and you may remember how to graph it without using a table of values. But if you're ever unsure, or if you're ever given a table of values, we can use that to help us find our points. So when we graphed these, they gave us a couple x values. They told us we're going to use the x value of negative 1, 0, and 1. So all we need to find is our corresponding y values in the second column. To do that, we're going to take our x value and we're going to plug it into our equation where we see an x, and then we're just going to simplify that expression. So for -1, I'm going to have y equals 2 times -1 minus 3. If we simplify that, 2 times -1 is -2 minus 3, or y equals -5. Okay, so that means my y value is -5. And I'm going to come over here and graph -1, -5. Left 1, down 5. Okay, for our x value of 0, we're going to do the same thing. This time we're going to put 0 in there. Let me draw a little arrow over here. We've got y equals 2 times 0 minus 3. Well, 2 times 0 is 0. So we just have 0 minus 3 is -3. So when my x value is 0, my y value is -3. We can plot that ordered pair, 0, -3. Now we've got one more we can do. We've got the x value of 1. So we're going to plug in a positive 1. We're going to scoot over here to do that. And I've got y equals 2 times 1 minus 3. Well, 2 times 1 is 2 minus 3 gives me -1. So my y value for this last x value is -1. Or sorry, yep, so we have +1, -1. And notice this creates a line. If we connect and extend our points, we're going to end up with a line that grows at a constant rate. If we had a bigger table, we could do more values in the negative direction, more values in the positive direction, but having those 3 points gives us a good picture of what that line looks like. Okay, we have another equation here. It looks a little bit different. We have 2x minus 3y equals 6. Our y is not by itself here, but we can still use a table of value to find our y values. So let's do that for each one of these. So if we use our first x value of -3, we're going to come right up here and plug that -3 in for our x. So I have 2 times -3 minus 3y equals +6. 2 times -3 is -6. Minus 3y equals 6. If we add 6 to both sides, because we're trying to isolate y, we get -3y equals 12. If we divide both sides by -3, we get y equals -4. So our first ordered pair is -3, -4. We go left 3, down 4. Okay, second one, we're going to plug a 0 in. I'm going to come over here and do that. I've got 2 times 0 minus 3y equals 6. Well, that just gives me 0. So if I divide both sides by -3, I get y equals -2. So my second ordered pair is 0, -2. It's right here. And my last one, if we plug in a 3 for our x, we're going to get 2 times 3 minus 3y equals 6. 2 times 3 is 6, minus 3y equals 6. We can move that 6 to the right side, and I get -3, y equals 0. If we divide both sides by -3, 0 divided by anything gives me 0. So my last ordered pair, -3, 0. It's going to be right here. Okay, so again, once we have a few of those points plotted, it gives us a general shape of what our line's going to be. If we had a bigger graph and or more x values, we could find some more y values.